With that said, I'll start off. And if you guys have, so let's start off with multiplication tables. Let's just do a two-digit number. So here is what I want to do. It's like sort of like a warm-up. You guys have learned multiplication tables in school, right? You go like 7 times 1, 7, 7 times 2, 14, 7 times 3, 21, so on. Or if you're from India, you would do 7 ones are 7, 7 twos are 14, 7 threes are 21, and so on. So what I want to do is attempt like a two-digit number, and instead of actually trying to do spend time doing like 7 times, saying 7 times 1, 7 times 2, 7 times 3, because that will give me time to think. I don't want to have time to think. I'm just going to go rote. So I'm just going to go 7, 14, 21, 28, 35. It'll be a little difficult for you guys to verify because it requires like an Excel sheet or somebody to actually sit down and calculate it. So I'm going to have to ask you to take whatever I'm saying for just for this part to on face value. And you'll know it if I make a mistake, because by the time I get to 10, I would have gotten it wrong. Something times 10 is very easy. So if the audience is willing, can one of you give me like a two-digit number, and I'll recite the multiplication tables in the format that I just mentioned.
23.
Did you say 23?
Yeah.
Okay. 23, 46, 69, 92, 115, 138, 161, 184, 207, 230. That was 23 times 1 to 23 times 10. I know it went very fast, so there's no way to verify.
77.
77, 154,
77.
Okay, so I'm starting. Yeah. 77, 154, 231, 308, 385, 462, 539, 616, 693, 770.
Amazing.
Thank you very much. Okay, well, let's move on to squares. Okay, why don't you guys, I won't spend too much time. Sorry, do you have a question?
Can I give you a three-digit number?
Yeah, you can. I might be a little bit slow, but let's try it out.
Okay, can you do 121?
Yeah, 121, 242, 363, 484, 605, say 726, 847, 968, 1089, 1210. Thank you very much.
Last night I was watching Shakuntala Devi.
Sorry, I didn't catch that. Could you repeat that?
The last night I was watching Shakuntala Devi.
Oh, okay. Thank you. Let's try squares. Can you guys think of like a two-digit number, and I'll try to square it? Can you, one of you, pick a two-digit number? And maybe I'll write it on the board. It might be easier.
25 times 25.
625.
Oh.
625.
That's easy. Yeah, got it.
Thank you, Ditya. Go ahead, Ditya. I'll give you another shot. Go ahead.
Ditya, give a harder one.
Okay. 89 times 89.
89 times 89 is 7921. Thank you. Thank you very much. So do you want to move on to cubes, or do you want to just do squares? One more square?
67.
Sorry, could you repeat that?
67.
67 square is 4489.
So what we need is what kind of like trick that you use and the answer. And
that's a very good question. The simplest thing in my case, this one, squares, was actually really easy because for whatever reason, I have a lot of them in memory. So mental calculation involves not only just calculating, but also utilizing your memory to be able to get to the answer. So this one, I didn't have to exercise much, like except for 89, I really didn't remember it. Then I realized immediately, okay, it's 8100. So 90 is 1 square. So 90 square was 8100. And then 1 square was 1. And then I did 2ab, 2 times a square plus b square plus 2ab. So 2 times 90 plus so that times 1, which is which is 180. So essentially I did 8100 minus 180 minus. So that's how I got, plus 1. Sorry, that's how I got to 7921. So it's a minus b whole square is a square plus b square minus 2ab. Okay? So it's pretty simple algebra there, not too much to worry about. And because you know a square, already a is in this case 90, then b is 1. You immediately get, okay, all you need to, because you immediately know 90 squared, it's 8100, because you know 9 squared is 81, and then 90 squared is 8100, you know 1 squared is 1. So it's like 81, and all you have to do is just do the 2ab part, which is 2 times 90, which is 180. So 8100 minus 180 plus 1. Make sense? And with any of these, or anything with mathematics or not just with mental calculations, you kind of like formulate an algorithm very quickly as it comes to you. Like you don't necessarily have to think about it, because you just think it's like tomorrow you ask me some other square, right? I might have gotten to the answer in a different way. I just wouldn't know. It is just that that's one of the beautiful things about mathematics, because the answers are pretty deterministic. So you can formulate your own methodology to get to the answer. Make sense?
It does, but I do have to think. You said you don't have to think much about it, but I do have to think.
Right. In this case, well, 89 I had to think a little bit, but the 25 I didn't have to think at all, because I already knew the answer. It's just one of those things, I already knew it. So, do you want to, I don't know how much time we have. Do you want to move on to cubes? Cube, do you know what a cube is? A number multiplied by itself 3 times. Like
67.
2-digit number.
67?
67 cube is actually 300763. I'll write it down.
Is that right, Ditya? Oh, yeah, she said it's
Yeah, I got it on the calculator.
all right.
Okay.
One more top 2-digit number.
I think you're on mute.
86.
86 cube. 86 cube is 636056.
Okay, I think I typed it wrong.
She said, so sweet. She believes you.
which is not a good place to be in. Don't believe me.
He was waiting for your show, Shiva. She's like,
Thank you very much. I'm glad I'm able to have enthuse this interest among you.
Oh. Mm-hmm.
Shall I erase
Erase
this so
it.
that you have some room? Was it correct? I don't
It
know.
was this correct? 636056? Okay, perfect. Do you want to do cube roots now? Do you guys know what a cube root is, Ditya? Like, okay. I'll just, you'll get the concept very easily. You're very sharp, so you're very smart. So 2 cubed is 8, right? 2 times 2 times 2. So the cube root of 8 is 2, right? So now 3 cubed is 27. So what will the cube root of 27 be?
backwards.
3.
3, there you go.
Very smart.
4 cubed is 64. So what will be the cube root of 64?
16.
No, 4 times 4 times 4 is 64. So the cube root is the process in reverse. What will be the cube root of 64? 4.
4. 4 times 4 times 4 is 64. You go the other way around.
The other way around. Now, so with that concept as mind, right? There's an interesting thing about cube roots when it comes. Before I talk about cube roots, right? I want to talk about perfect cube roots and imperfect cube roots. Now, 64 is a perfect cube because 4 cubed is 64. Okay, 65 is not a perfect cube. Why? Because there's no integer number that multiplied 3 times gives 65. So cube root of 65 is an irrational number, right? Now, if it's perfect cubes, it turns out at least for 2-digit numbers, and you can look this up into the internet, there's an elegant method to find the cube root if you just know the first 10 digits. And it's not you don't have to call it a trick. It's just a property of cube roots. But of course, imperfect, there is no way out. You have to do those calculations. And this method also kind of works for 2-digit. If you try to extend it to 3-digit, it becomes an order of magnitude much, much harder. So what I'm going to do is I'll try to attempt like a cube root of a 2-digit number, where meaning you give me a 2-digit number, you cube it and give the cube, and I'll take the cube root, because as I said, that's a perfect cube, 2 digits, that's easy. And to challenge myself, I'll actually try to go take a 3-digit number, cube it, and I'll take the cube root. Maybe we can even do a 4-digit if we have time. And we'll go one step and do an imperfect cube root. And now imperfect cube root, there's no tricks, no way around it.
83.
Sorry.
No, that's okay. Okay.
405224.
405224. 405224 is actually 74 cubed. Okay. And as I said, there's a nice trick to cube roots of perfect numbers. I mean, especially if it's 2 digits. You can kind of split the number. You know, 405 lies between 6 and 7, 7 cubed and 8 cubed. So 7 goes here. And 4 cubed is the only one that ends in a 4. So you get 74. So you don't, this is actually a simple problem. You don't have to think too much about it. Okay? So this is, but as I said, for perfect cubes, if it is a 2-digit number, you can get it really fast. There's a trick. I hate to call it a trick. It's a property of cube roots. Now let's make it harder. Let's try to give me like take a 3-digit number and give it to Soumya, and she will write it on the board, and I'll try to extract the cube root. Okay? Now I might hear the number, so maybe it's okay.
Can you text it maybe in the WhatsApp group, and I will. Yeah.
It will also be a good idea. We can text.
So you want me to write the number she's
Yes.
giving, right?
Yes.
And you won't see it.
I won't see it till you actually tell me that I can start seeing it.
What does it matter when you see it? I don't know.
As soon as you finish writing, because it'll take some time to write the number there. So that I don't want to factor that into calculation time.
Is Ditya sending it? Okay, you're gonna send it. Okay, sweet. Oh, she did. I wrote it.
Okay. You wrote it. Okay. Thank you. So the number is 327082769. Okay. I'm going to try and extract the cube root of this number, right? It is
Come on.
689. Is that right?
Yes.
Thank you. Thank you.
But this was also a perfect cube.
It is also a perfect cube. Basically, I kind of split the number into three parts, and this gave me the 9. But this part was a little bit harder because I had to dig deeper and I had to think, okay, 68 cube was 314432, 69 cube was 328509. Then I did like 68.9 cubed. I didn't get it very exact. I just did like a minus b whole cubed is a cube minus b cube plus 3 minus 3a squared b minus 3ab squared. So the 3ab squared term is not very important. So I just got that, and then I was able to get to this answer. One more. Do you want to do like a 4-digit number now? Do you want to take a 4-digit number and do like and cube it, and maybe just that last problem, because I don't want to take up too much time, and then give a 4-digit number, cube it, and give it to me. Give it to Soumya rather.
Yeah, she's going to send it to me.
Send it to. And by the way, Shakuntala Devi did do a 4-digit, I think a cube root of a 10-digit number. So when you give me a 4-digit number, that number will be either 10 digits or 12 digits, depending upon what the number is. So I'll attempt that. I'll try to attempt that. Not sure I'll be successful, but I'll try. I'll look around, I'll look away. And Ditya, you are an amazing, not just you are such an engaging and amazing participant. I really, really appreciate that. And this is exactly what I hope to achieve with shows like this, to make sure that we have math inculcated among youngsters.
I sent it.
Oh, you sent it?
Thank you, sweetie.
Okay. Soumya is writing it down, and once she's done, I'll go ahead and take a look at it. Okay. I'm not sure if I'll get this right, but I'll try.
Okay, I think I will.
Okay. Okay. So the number is 117-433-042-273. $4897? It's correct?
Is that right?
Okay.
Very
Okay.
nice. Good job.
How did I do it? Very similar. Factored it. 4 parts. I already knew this was a 7. And then this part was, these 2 digits were harder. I actually did 4900 cubed, which gave me 117,649,000,000. And then 4800 cube was 110,592,000,000. And then there I started interpolating again. A cube minus 3a square b minus 3ab square a minus b whole cube plus b cube minus b cube. Using that formula, I started getting to this homing in on this answer. Make sense? Okay. One last question. I know we are out of time. Instead of doing this time, I'm going to make the problem harder. These are all perfect cubes. So there's like a nice method to this, right? To some extent, you can kind of get to it. Now, let me pick a number at random. Let's try anything between 4 digits and 6 digits, because these are harder. These don't have a perfect cube root. So I have to do like a lot of calculations to get the answer. So maybe to make it simple, let's do 4 digits perhaps. And I'll try to get the answer to 4 significant digits if I can.
Any 4 digits.
Any 4-digit number.
Any 4 digits you can pick.
Any 4, random. This is much harder.
You tell me, I'll write it. Pick
7,
any 4
9.
digits. Yeah. Oh, yeah. Okay. Miss Lokesh is it. Yeah.
7, 9.
7, 9,
1, 9. 1, 9.
1, 9. 7, 9, 1, 9?
Okay.
7919, right?
Okay, we'll change 7917.
7917. Okay.
7917. It is 19.93.
I have to calculate. Sir.
Actually, just take the cube root function in the calculator. If you have a
Or just multiply 19.93 times 19.9.
or take a calculator and you can do the cube root function.
That's the better way. Multiply.
Okay, no, I'll do it. You know what? I'll do it. Take the cube root function, because on your iPhone, right, you have this. You become it becomes a calculator. So I'll just do 7917, and the cube root function is here.
Yeah.
19.9.
Close.
Very good.
19.93.
Yeah.
It's kind of hard
So-
because these are imperfect cubes. Kind of hard. So I actually wanted to go and do 5th through